As many of you know, I've been working in my spare time on quantum gravity for many years, and I thought I'd just give an illustration of one of the major points of quantum gravity that I'd like to raise, since this relates to why this question of why the electron doesn't just fall into the positively charged nucleus of an atom, right? So an electron is negatively charged, a proton in the center, nuclei are positively charged. Yet they exist in stable orbits around the nucleus. They do not orbit like planets orbiting the sun or anything like that. Instead, they exhibit wave characteristics. We call that is sort of smeared out in what was known as a wave function around the atomic nucleus. But the way that manifests specifically, they appear in a given location around the nucleus for an incredibly brief amount of time, then pop up somewhere else, then somewhere else, then somewhere else, then somewhere else, then somewhere else, and the sum of that creates a sort of cloud, electron volume probability density around the nucleus of an atom. And I've been hunting around for satisfactory answers to this question, and I've gone on Stack Exchange, and none of these people have answered the question satisfactorily, in my opinion, on Stack Exchange. I went on the Texas A&M website, and likewise they didn't answer the question satisfactorily on there. Most of the answers, if they're answering this question at all, they just seem to be saying because quantum mechanics, and that's never really good enough, in my opinion. The real reason why, and I don't think that this especially could be refuted, and I think it would be backed up by a substantial amount of evidence from observation, is that the electron is kept away from the nucleus due to radiation pressure. So what we know about the background of space is that there's this thing called the cosmological constant and this phenomenon of vacuum energy. So we know that the background emits energy seemingly spontaneously. The current best thinking on this topic is that particle-antiparticle pairs are created and annihilated spontaneously. I've never warmed to that idea. I don't like that idea because, in my opinion, it violates energy conservation and leads to unsatisfactory and untenable ideas, I think, such as the eternal inflation or internal expansion of the universe resulting in heat death, which I don't warm to it as an idea. I don't see it as physical. I don't see it as reflecting physical reality. It violates a core principle of all physics, which is the conservation of energy, and I don't see this happening. So, but that's not entirely the truth. Since the electron actually, it does enter the proton from time to time. It does get very close to the proton. When it gets very close to the proton, it exchanges particles, electroweak particles, W plus and W minus particles with the proton, and this is what creates any force of attraction between the electron and the proton and keeps the electron in a relatively stable orbit, right, around the atomic nucleus. What the force keeping it away from the electron is not the force of spontaneously created and annihilated particles in the background. Rather, it is photons being deposited in the background, in my model at least, by tunneling electrons. So these electrons, obviously, if you get two negatively charged electrons close enough to one another, they'll repel one another, of course. We know that this force of repulsion manifests as the exchange of photons. So what we have in the background, I think this is one of the ideas that implies heavily or greatly implies that there is a background of tunneling electrostatically negative particles, i.e. electrons. So you get electrons in the background emitting photons, and any electron that's bound in orbit around an atomic nucleus, that is being pushed away from the nucleus, in essence, by that repulsive force from the background, that repelling force, those emissions of photons there. So that's what's going on. And every time an electron in the background absorbs a photon, its wave collapses, and it absorbs a photon, it disappears to a new location. It might not even be the same electron each time. We don't know that. I don't think there's any way of knowing that. I think we'll never know that. And it could be via the exclusion principle that an electron of a similar, I think, energy pops up in that location to then again emit a photon or emit another photon, and that really in the universe we have to treat any and all particles as virtual particles. However, there are domains that we are aware of in nature where this doesn't occur, where indeed the electrons fall into the protons of a nucleus. These are neutron stars. So when supernovae collapse, certain supernovae, I think they are type 1a supernova, I think are capable of collapsing into neutron stars, if I remember correctly, whereas type 2 supernovae collapse into black holes or pulsars. I'm not certain. In any case, what we have on the outer layers of neutron stars is this lattice structure of neutrons containing free electrons which float around between the lattice structure. And at the very core of a neutron star, there's this positively charged quark gluon plasma formed of the fusing together of all those protons. And we see in those domains the forces between these negatively charged electrons and these positively charged protons balance pretty much exactly. And these, of course, give off light, but that's not capable necessarily of pushing against any electrons as a part of the neutron star, since all these free electrons have been absorbed within its structure, if you see what I mean. And I think this is quite a good vindication of my model, since we're quite aware of the vacuum energy. I think it would be unreasonable to suggest that energy in the background, energy of the vacuum, has no effect at all on atomic structure. And I think the idea of tunneling electrons just allows us to remove one assumption from our models that just seems to me unscientific, and that's the idea of these creation and annihilation operators, these particle antiparticle pairs that appear and annihilate one another, which we'll never be able to test that directly. It violates energy conservation. I don't like anything that just spontaneously bursts into existence, really. It just doesn't seem like science to me. It seems like some woolliness, waffliness. There's like something put in place just to explain it away, really, more like. So yeah, that is, I think, the real reason why atoms retain the structure that they have. We see electrons popping up in the background, repelling the electrons that are in orbit around the nuclei of atoms, keeping them largely away from the nuclei that they orbit. Not always away from the nuclei. Very often, sometimes they do get quite close to it. Likewise, sometimes also they get quite far away from where they're usually supposed to be in the electron volume probability density, and can actually exert forces over other atoms, which gives us van der Waals forces, gives us chemical bonding, actually gives us gravity as well, I suspect. Thank you for watching.